Okay, today we're going to go through a little bit of algebra review. We're going to try to pull back and sort of dust off some of the cobwebs from our algebra class. Perhaps we haven't used it in a while or over the summer. We need to remember those rules of operation. It's going to become very important as we progress through the year. So today is trying to refresh your memory on how to solve for a variable. So remember that our orders of operations, there's four. You want first, let's do inside the parentheses, then take care of the exponents. You're going to multiply and divide left to right, and addition and subtraction. Now remember, these orders of operations are when you're taking and trying to solve for numbers. You're actually sort of going through the operations to reduce something down. But when you're trying to solve for one particular variable and you're rearranging an equation, we're actually going to go, instead of 1 through 4, we're going to go in reverse order. We're going to think about this in terms of bottom to top, not top to bottom order. So we're going to solve or move anything that's added or subtracted to our variable that we want to isolate first, and then we're going to do any multiplication, division, exponents, and parentheses, sort of going upwards. The other thing that's probably the most important thing is what you do to one side you must do to the other. So let's take a look at a couple of examples. Okay, so the first example, we're going to take a real basic one. This we're going to see later on in the year, where f is equal to ma. Now if I want to solve for, say, m, so I'm going to take and circle it, because that's the guy that I want to isolate, get on one side by itself. And it doesn't matter to me which side of the equal sign it's on, since it's in the numerator. Remember, all the variables we want to solve for will be in the numerator. Since it's on the left side, I'm going to leave, or on the right side, I'm going to leave it there, and that's okay. So opposite operations, there's nothing added or subtracted to m, but the a is multiplied. So I'm going to divide by a, and what I do to one side I have to do to the other. A divided by a is 1, so that cancels out, and I'm left with f divided by a is equal to m. And that we could then, if we knew what f and a were, we could find out what that actual numerical answer is. Okay, let's take a look at another example. Let's say we had something like v equals a minus b all divided by t. And now, again, I want to get, let's say we want to solve for a again, all by itself. So here again, we'll take, we want to get rid of the t first before we do this subtraction, because it's really a divided by t and b divided by t. But if we move the t over first and then take care of that subtraction, that'll simplify things for us. So this is all divided by, so I'm going to take and multiply through by t, and what I do to one side I have to do to the other. So again, the t would cancel out, so we'll cross that out. So I am left with v is equal to a minus b. Next step then, again, I'm looking for a. B is subtracted from a, so I want to add b, opposite operation, to both sides. So here I will have tv plus b equaling a. And that is in its simplest form. We could stop right there, and then if we knew the numbers, we could substitute those in. Okay, let's try another one. Let's see if we can, what happens when we have something that is squared. So let's say we had d equaling 1/2 at squared, and we're going to solve for t this time. So we'll take and circle that t, because that's the one we want to isolate. So whenever we have a fraction, or something in the denominator we multiply through, that's the same as multiplying through by reciprocal. So I'm going to leave that initial equation alone. I'm going to rewrite it over here. So I want to get rid of the half first. So I'm going to multiply both sides by the reciprocal of 1/2, which is 2 over 1. So what I do to one side, I have to do to the other, 2 over 1. The 1/2 now cancels with the 2, and I'm left with 2d is equal to at squared. Remember, anything over 1, you don't have to put that 1 underneath it. Next step then, this is a times t squared, so opposite of times is division, so I'm going to divide through by a on both sides. The a cancels out, so I now have 2d over a is equal to t squared. And if you recall, the opposite of a square is a square root. So if I take, I'm running out of room here, so I'm just going to put the square root symbol. What I do to one side, I have to do to the other. So then, going to the side here, I end up with 2d divided by a square root is equal to t. And that is our final answer. So remember, the opposite of a square is a square root, so the square root of t squared is just t by itself. Okay, let's try one more. Let's say we had, okay, so let's try this one. So d equals vt plus 1/2 at squared. Let's try that one. This time, let's take and solve for the v. So here, we're going to take this whole side. All of this is added to the vt. So we're starting at the bottom. So we're going to take this whole thing and do opposite operation. It's added, so I'm going to subtract it from both sides. 1/2 at squared from this side, minus 1/2 at squared from that side, and let's see what we end up with. So the 1/2 at squared is canceled, and we end up with d minus 1/2 at squared equals v times t. Okay, so you see we moved that whole thing over as one variable, didn't change it, just subtracted the whole thing over. Now we want to again solve for v. This is the multiplication between here, it's v times t. So we are going to do the opposite operation. Switch colors again. Opposite operation, we're going to divide by the t. What we do to one side, we have to do to everything on the other side. So the t's cancel out, and I'm going to distribute the t. So we have d divided by t minus, here, let me go back to black. So we have d divided by t minus the 1/2 a, but now t squared divided by t, so one of those t's goes away and we're left with 1/2 at is equal to v, and that is our final answer. So if we knew what dt and a were, we could analyze that and come up with a final number. Okay, so practice these. We're going to be doing a lot of them in class as we work through problems, but it's real important that you sort of become comfortable with doing the algebra.